Now, put very simply, this whole thing is just the same as y. And in the short term, as you get better at using algebra, if you ever see this on a problem, you can literally just write the same exact equation, but replace this with a y, and you will get the same answers. Welcome to Calbeckistan, the place where anybody can learn math. I'm Mr. Calbeck, and today we're going to be talking about function notation, a new way of writing functions that gives us a little bit more information than we have before. Now, if you tuned in last time, we talked about functions and what they are and how we can talk about them. But we learned that we have inputs and outputs for our equation. Inputs are x, outputs are y. And I asked you the question, what number is y? And it turns out that we actually can't answer that until we know the value for x. Once we know the number that x is, then we can understand the y. In fact, y has almost no meaning until we have an x. So the way that we usually talk about this, we talk about x as our independent variable. The independent is the thing that makes the decisions in the relationship. Y is the dependent. So you can remember it this way. How many of you out there are independent people, independent thinkers? Right? You do what you want. Nobody's going to tell you what to do. You're independent. You're going to make your own decisions. People are going to have to work around your ideas. You know what that means, being an independent person. Dependent, a lot of you may know some people that are dependent in relationships. You know the people I'm talking about. Yeah. Oh, I just love him so much. But isn't he like mean to you and like not nice? Yes, but I just love him. I just need him. Okay, that's Y in this relationship. X makes all the decisions and Y just goes along with it. Y should probably find Y's own lifestyle, but you know, Y's dependent, so Y gets stuck in a bad relationship. So, independent, dependent relationship. Now, the problem is Y, because it really doesn't have any meaning apart from X, this isn't a great option. If I ask you what Y is, I first need to know what X is. So we're going to show you a new notation that means the same thing as Y, but it looks a little bit different. I know this looks a little bit weird. But before you click away from the video, I want you to understand this is not f times x. All right? This whole thing, even though it looks strange, all it means is it's a big way of writing y. And I want to try to show you why it is that we use that different notation. Get it? I said why? That was a joke. Get it? A math joke. Never mind. The reason that we talk about this as f of x instead of y is because remember, y, the output of the function, doesn't really have any meaning until we know what the x is. Now that information is hidden in the y. If I told you y equals 11 or something, that doesn't tell you any information about the input, despite the fact that the input is what gave the y its value. Now you could probably figure out in this that the input must have been 6. Now with function notation, this right here, I actually can write all of that information in one thing. It not only tells me what the output equals, but it also tells me the input that gave me that output. And this is the way you write it. Notice that the variable here matches the x. If I replace this with a 6, the output is 11. Now remember, this whole thing means y. This is exactly the same thing as writing y equals 11. The difference, though, when using function notation, I also found out what the input was that gave me 11. Remember, inputs and outputs, that's the whole concept of the function. So for me to have an output tells me what button was pushed on the vending machine first. All right, a couple of other things about this. Now, first thing, we usually use the letter F. That stands for function. That's all it means. Remember, this whole thing just means y. When I'm talking about how to say this out loud, I don't say F parentheses x. The way that I write this is F of x. Not F off x. Don't do that. This is F of x. All right? So F of x is there. Now, in the previous situation we talked about, where we had the equation here, and I told you that the input of the function was 6 and the output was 11, the way that I would say this, instead of F of x, I would say this is F of 6. And again, that tells me the input of the specific input in this equation was 6. Hopefully you're tracking with me a little bit. There's a couple of other reasons why we like function notation instead of just using y all the time. I can have problems, and as you go along in math, some of you may already know this, you can have multiple equations in one problem. Now, if I have multiple equations, maybe something like this, and I asked you, okay, what does y equal? First of all, you should be like, well, remember, y doesn't have any meaning unless we know x. And secondly, you'd be like, okay, well, which y are you talking about? There's 2 of them in the problem. Again, that doesn't helpful. When I use function notation, I can actually differentiate very easily between different y variables. So again, I can use the variable f for this one, and this would be f of x, but I don't have to choose f. Anytime I write something like this, you can use any letter that you want. You can use F, G, H. My students always ask, can I use X? Sure, you can use X of X. You can use any variable that you want. If you go really far in math, you're going to start seeing them use other language letters. You'll see Greek letters and things like that in here. You can use anything that you want. So now I have way more information. If I ask you what the y is, now I can be specific. Say, I want to know what f of x is. No, I don't want to know f of x. I want to know f of 3. So if I wanted to know f of 3, what does that equal? All I need to do is plug 3 into the function. Now again, it's just way, way easier and faster to say, okay, which y? Oh, the first y. Y when x is what? Oh yeah, okay, find the first y when x is 3. It's kind of long to say, and mathematicians are notoriously lazy. We want to say as few words and as few symbols as possible. So this is f of 3 tells me that right away. I want to know what f of 3 is. I want to know what y is when I plug 3 into this equation. So if I plug 3 in here, I can write the 3 in there, and I find out that my answer is actually 3 again. Or you could do the exact same thing with the g. I could say, what is g of negative 10? Okay, you know right away what I'm talking about. I'm talking about this equation, and I want to know what happens when I plug in negative 10 into the equation. And all you need to do for this, if you see this, this means that the x has been replaced with negative 10, and I'm going to plug in a negative 10 in there. And so I find out that my actual answer here is negative 33. And that's function notation. It's a more efficient way of writing the concept of a function. It tells me the output, but not just the output. It also tells me that the output came from an input. It tells me exactly what that input was. So it is a much more efficient and helpful equation. Stay tuned next time where we start putting really weird things together, and I start combining functions together, and you can find out that you can plug in anything that you want into a function. I'll see you next time.